Flammable gases that are not accurately detected can harm the environment, cost companies valuable resources, but most importantly, put lives at risk. Did you know that traditional gas sensor technology hasn't evolved in over 40 years? Polisters have been in use for nearly 50 years, and NDIR, infrared, was introduced in the 70s. For many businesses, this is still the first line of flammable gas defense for their frontline workers. NDIR and Polister sensors can only be calibrated to a single gas, inaccurately measuring or ignoring other combustible gases that are in the air, resulting in increased risk and costs via false alarms. Further risks include poor accuracy, sensor poisoning, frequent calibration, and replacement cost. Polisters potentially failing and still displaying 0% LEL, and NDIR cannot detect hydrogen or acetylene. The Molecular Property Spectrometer Flammable Gas Sensor by Nevada Nano has entered the industry to disrupt traditional sensor technology and provide reliable detection for your employees. True LEL finally exists. The MPS sensor simultaneously monitors multiple gases with a single sensor, providing accurate indication of the level of combustible gases faster than traditional sensors. The MPS sensor can report 0 to 100% LEL for over a dozen gases and most other hydrocarbons with great accuracy, a feature we call True LEL. We have developed the basis of our sensing technology with the U.S. Department of Defense in the most challenging gas detection applications and are now available for the safety and control systems market. The MPS gas sensor requires no field calibration, is poison resistant, detects hydrogen, self-monitors, has no drift, and operates in up to 100% humidity, making false alarms a thing of the past. Here we demonstrate how the MPS performs against the competition when calibrated to just methane. The MPS can accurately detect multiple combustible gases accurately from one calibration, but traditional sensors are only accurate to the gas they have been calibrated to. When using traditional sensors, there is a real risk that hydrocarbons on your site will not be accurately detected, which puts your staff at risk. Additionally, we completed live tests and exposed the MPS, NDIR, and Polister to butane, hydrogen, and methane released into an environment at 50% LEL. The first test with methane resulted in all sensors accurately measuring the gas and reaching both alarm levels. But when we tested butane, all sensors detected some level of the gas, but only the MPS sensor provided an accurate reading. With hydrogen, the Polister underdetected the gas, resulting in a potentially dangerous masked alarm. The NDIR showed no detection, missing all alarms. Only the MPS provided accurate detection. For the final test, all sensors were calibrated to 50% LEL methane and exposed to an environment with 10% LEL methane, 10% LEL butane, and 20% LEL hydrogen. All sensors reported some level of gas, 21% by the NDIR, 32% by the Polister, and 40% by the MPS. Only the MPS reaches the important second alarm level, potentially saving lives. Put the MPS technology to work. Lives are depending on it.